So, good morning, everyone. From today's class onwards, we are going for another problematic one important problem of cloud computing that we call as the task scheduling. Already, we have seen one of the very important problem of cloud computing, that is resource allocation. So, once the resource allocation is done, means once the computational resources or virtual machines or the physical machines are allocated to a user application, the next work is how to schedule the task in these resources, right? That's why task scheduling problem is very popular one. And in this task scheduling problem, it is a quite old problem. I will not say it is a new problem, but the environment in which you are applying task scheduling is new, right? Like you are applying the task scheduling in cloud computing, that is new. But task scheduling in the traditional system, like you can say cluster computing, grid computing, parallel distributed computing, or somebody sometimes will call it a multi-processor scheduling, that is not new, right? But task scheduling in cloud computing is new with respect to various challenges, right? So let us discuss some theory parts. Then I will tell you the problems, how to solve these problems using task scheduling. So you can expect some good number of questions from this course in your end semester examination. So you know that cloud provides three services. One is our infrastructure as a service, another is platform as a service, another is software as a service, right? But whenever you focus on infrastructure as a service cloud, here the resources and services are provided to user in the form of leases that we have already seen in the case of resource allocation. You know, a set of leases is given to you, and on the other hand, you have a cluster with a set of nodes. What you are going to do? You are going to assign the leases to a set of nodes that are present in a cluster, right? That is the objective, right? What you are seeing in the resource allocation. So you can see, specifically in this IS cloud, we refer this task term as leases. But many people also refer by task. Some people refer by subtask as well, where they assume that the task is very huge. Some people they are referring applications, okay, which is nothing but a directed acyclic graph, right? So if you see such scenarios, the user can control the resources safely because of the efficient virtualization technique. You know VMware, right? VMware is a virtualization technique. KVM, K virtual machine, is a virtualization technique. Or XEN is also virtualization technique, or we call it a hypervisor. So these hypervisors enable us to apply the virtualization techniques in on top of the physical infrastructure, right? So user can monitor the resources that are allocated for his application through these virtualization solutions. Most people are using VMware because we have Windows operating system. We are installing VMware. In VMware, we are installing Linux operating system to do our work without explicitly separating Windows with Linux operating system. So one of the advantages you are going to get in the infrastructure as a service cloud is that computational capacities provided to the end users are flexible and efficient. Obviously, due to the concept of elasticity, due to the concept of the scalability, you can scale up the resources, whether it is automatically or it is based upon the manually, you are able to do it, right? So this is the basic advantages whenever you are going for infrastructure as a service cloud. As a typical example, if somebody wants to know what is the cost of a virtual machine, if you want to deploy a particular virtual machine in Amazon EC2, okay, You are aware of Amazon Web Service because we have already performed one experimentation in Amazon S3. So similarly, if you want to create a particular virtual machine in Amazon Elastic Compute Cloud, Amazon EC2 is a specific service provided by AWS, Amazon Web Service, like our S3, right? Simple storage service. Okay. If you see here, the virtual machine is leased to the user based upon the requirement of the user, or user has explicitly mentioned the size that is mentioned in the dashboard of Amazon Web Service, right? So these are leased to the user at the price of 10 cents per hour. 10 cents means 6.13 rupees, although these figures are varies with respect to the data, but if you see 100 cents is equal to $1, but now the figure may be different. So if you assume that 100 cents in a dollar, then you can say 10 cents you have to pay per hour. That is nothing but 6.13 rupees. Okay. In our childhood time, maybe you have also seen that there is a network, the net cafe is there, internet cafe is there, because at that time internet is not that much available, right? So we are going to internet cafe, we are using, we are browsing the internet, we are filling the application forms of various jobs and various entrance examination in the internet cafe, and for our basis we are paying 10 rupees or 15 rupees like that. Similarly, if you want to create a particular application in which you require virtual machines, you can take this virtual machine from Amazon Elastic Compute Cloud with 6.13 rupees per hour. Now, each VM, once a VM is given to you, what is the configuration of that VM? Or we call it what is the configuration of that instance? If you see, it is having a approximate computational power of 1.2 gigahertz Opton processor with 1.7 GB memory and 160 GB of disk space. Okay, this is a typical example. This is not a generalized one, right? If you are concentrating a different virtual machine, maybe the power of that virtual machine vary with respect to the computational power, with respect to the memory, with respect to the disk space. For example, when a user needs to maintain a database with a certain disk space per month, assume that you are using Google Mail. In Google Mail, you are using Google Drive, Google Mail, and so many applications associated with the Google. Assume that your Google Drive is filled with 15 GB, right? Or your Gmail is filled with 15 GB, because you know that all the services associated with a email account is limited to 15 GB. So once 15 GB is filled, what Google is saying, you can purchase the space, right? And that space cost is you have to pay 100 rupees, let's say per month, right? You have to get additional 5 GB or something like that. You have to pay 100 rupees per month. That's why here also you can see. So if you want to purchase that disk space per month, we have to rent that particular disk space. So in this context, if you see, he or she can rent a number of virtual machines from the cloud and return them after that month. For example, you want to store something in the Google Drive for 1 month only. So for this 1 month, you are exceeding 15 GB. So what you are going to do? You are going to pay this extra amount for 1 month only, because after 1 month you will delete that particular application or software from your Google Drive, and you don't want to give access to other users. So in that context, if you see, whenever you require more resources for that particular month or that particular day or that particular duration, you are going to pay the extra charges to the cloud service provider. So in this case, the user can minimize the cost, because purchasing 5 GB, suppose I want to purchase a 32 GB pen drive or 16 GB pen drive or 8 GB pen drive, After 1 month, I do not require that pen drive. What will happen? So your cost will increase. The cost of the pen drive may be more instead of purchasing that thing from the cloud. That was space from the cloud. Suppose I am getting in 100 rupees, pen drive cost is 600. So you are paying 6 times more because after 1 month, that pen drive is no more required by you, right? Similarly, user can add or remove resources from the cloud to meet peak and fluctuating service demands and pay only for the capacity used. And the number of resources required for a particular user or a client or a enterprises like Flipkart and Amazon, they cannot predict. In a particular day, the number of users may be huge. In a particular day, that number of users will be less. So there is always a fluctuating demand. So in order to deal with this fluctuating demand, what you are going to do, you have to switch to the cloud so that based upon your fluctuating demands, automatically the services, the resources will be allocated to your application. And the cost required for this thing is very less. Now, cloud computing is emerging with growing popularity and adoption, not only in research, but also in the business community. Both business, if you see, due to this COVID-19 situation, many people, those who are not comfortable in Google Meet or let's say Webex or Microsoft Teams or whatever the online platforms are there, they are reluctant to use prior to COVID-19. Okay, but due to this pandemic, people are heading towards the cloud computing, and many enterprises are relying on the cloud computing. They have also expanded their business into cloud computing. Right? So its popularity is not only limited in the academic community, but also it is equally important in other communities as well. But one of the important points you can remember here, if you go to look a particular data center, there is no data center that has unlimited capacity. There is nothing called infinite. People are saying cloud has infinite number of resources, but practically saying it is not having infinite number of resources, right? The resources is finite. For example, let us take a small example. For a newborn baby, okay, let's say when the child is at age 5, so suppose the child can call roll number 1, let's say serial number 1 to serial number 10. So for that child, you can say 100 is an infinite number. Okay. So for us, let's say we want to go in a ride. In that ride, let's say we can ride up to 500 kilometers. So for us, 1000 kilometers is an infinite. Similar cases, you can see the resources that are required by the data center or from the data center by the user, that is very huge. Okay, suppose I need maximum of 100 GB, but data center is having data in the yottabyte or gigabyte or something like that. So now for me, the resources that are provided from the cloud computing perspective is infinite. But frankly saying, there is no data center with unlimited capacity. So one day will reach where the data center, whatever resources are there, these resources may be occupied by the needy customers, right? In that case, what you have to do, you have to move from one cloud service provider to another cloud service provider so that you can meet the requirements of a particular customer. That's why it is saying, in case of significant client demands, the case where there is a significant client demands, what you are going to do? It is necessary to overflow some workloads to another data center. For example, you have data center 1, which is under Google, another data center, let's say DC2, under, let's say, Microsoft. Okay, the amount of space is there in the DC1 is infinite, we are mentioning, but if you see, you are go on deploying the application, the resources are not infinite, right? Resources are finite only, they are not unlimited. So if you assume that once these resources are occupied by the customer, Google may request to the Microsoft data center if the resources are free in the data center too. Google can request to the Microsoft to borrow some of the resources from that data center, right? Or Google can ask another data center, let's say data center 3, which is under the same organization, to provide the services to the customer. In that context, if you see, sometimes that Google is a provider, but whenever Google is seeking resources to the Microsoft, Google is now treated as client and Microsoft is treated as a server, right? So you can see here, these workloads sharing can even done between the private cloud, between the public cloud, or between the private and public cloud as well. So you can say this workload sharing, if you see in the overall sense, you can say it is based or it is going to be done in the hybrid cloud, right? So these data center switching that load from one data center to another data center may be done by a single cloud service provider, or moving from one data center to another data center may be done between two different cloud service providers, right? That's why we say this load workload sharing can be within private cloud or public cloud, or among the private cloud or among the public cloud, or in overall sense you can say in hybrid cloud as well. So the workload sharing is able to enlarge the resource pool and provide even more flexible and cheaper resources. Okay, so the workload that are assigned by the user to the cloud service provider, these workloads can be solved using the resources of the cloud data center. So these resources in the data center is also sometimes called as a resource pool, right? In the pool of the resources, you are giving a small amount of resources for a particular user's application, right? And this resource can be expanded to any number or shrink to any number as and when required. To collaborate the execution across multiple cloud. So whenever we are talking about multiple data center, we are also thinking about multiple cloud by assuming that each and every data center belongs to one cloud, or they can form a one cloud, and this is operated by a cloud service provider. So if you see in that angle, we need collaboration among multiple cloud. The monitoring management component is a monitoring and management mechanism is a key component and required consideration of provisioning, scheduling, monitoring, and file management. What is the meaning? The meaning is that if you are managing the resources inside your boundary, then it is okay. But whenever you are collaborating this work with others, whenever we are collaborating a single work with others, what happens? Our result and our performance is always depends upon others' performance as well, right? Like in your BTech work also, you can say you are allocated a research topic or a problem with three students. So the performance of the project is depend upon each and every individual person, right? If one person is not performing well, it will definitely impact the person who is working, right? That's why the main key component in this case is monitoring the resources and management of the resources, right? And also in the accounting is also one of the major role, because you have to decide who is going to get how much revenue after the service is rendered, right? So in this case, you can see provisioning may create a problem, that is resource provisioning. Scheduling, how you are dispatching the request to the data centers of the cloud service provider, that is an important one. Monitoring of the resources, whether the services are provided or whether a particular system is working or in the idle state or in the sleep state or the server or the resources is crashed. Okay, everything you have to manage, because sometimes if the load is very high, so there may be a problem that the server is crashed. So that type of failure also you have to deal with whenever you want to make collaboration with multiple cloud. And you have to also ensure that how these things will be monitored and which resource should be monitored by whom, right? One of the typical example, if you see, OpenZyrus, a cloud computing test bed, consists of 14 geographically distributed data centers. So it is having 14 distributed data centers in various parts of the world, right? If as it is present in various parts of the world, then you can say they are under different administrative domains, right? Let's say it is present in X region, their administrative domain is different. Y region, admin is there, administrative domain is there. So with respect to these 14 data center, the administrative domains are different. Each data center manages at least 1,000 ports independently. But this is also a very small figure. But if you go for today's data center, it is having more number of ports as reported in this particular statement, right? So see, these 14 data centers are collaborating each other. So whenever there is a peak demand, so one data center can request another data center to share its workload. Okay. And similarly, a data center may be underutilized. That data center may ask other data center to assign some of the workloads so that the resources of that data centers in the overall scenario, or in this case it is 14 geographically distributed data center, can be balanced. Now, let us see the cloud system in which we are going to apply these task scheduling algorithms. So, if you go for that system, we are considering infrastructure as a cloud system. We are not considering platform as a service or software as a service system. So, in infrastructure as a service system, a number of data centers participated in a federated approach, and these data centers may be belongs to different cloud service providers. They are not belongs to a single cloud service provider. These data centers deliver basic on-demand storage, computational facility, network, all the resources they are providing based on demand self-service characteristics of the cloud computing. The provision of these computational resources is in the form of lease, but these leases are going to be assigned to the applications. With respect to your applications, I am creating a virtual machine. On that virtual machine, you are going to run your application. These resources within a data center form a cloud. So generally, we assume that these data centers can form the cloud and can provide services to a set of customers. So here, if you see, the virtual machine is a abstract unit of storage and compute capacities provided in the cloud. So each and every virtual machine is having a processor. Each and every virtual machine having a storage space. Each and every virtual machine having a computation of its processor, right? So without loss of generality, what we can assume here, VMs from the different cloud offer you different stacks. The first cloud is creating a particular virtual machine. If you see the configuration of that virtual machine, and if you compare that virtual machine that is with another virtual machine that is created under another cloud service provider, then what you can see that there is a difference between the VM created in the first cloud, VM created in the second cloud. That's why it is saying VMs from the different cloud offered is different types or different styles, each of which has different characteristics, right? Their configurations are different, their processors are different, their computational power is different, their storage power is different, so they may be delivered in the different styles. For example, they may have different number of CPUs, amounts of memory, and network bandwidth as well. Okay, so the computational characteristics of different CPU may not be same in a overall sense. you cannot expect all people will create a similar kind of a virtual machine in order to run their applications. So one person maybe they are they are they are very habituated with the technical terms. So they know what kind of virtual machine is best suitable for their application. Now we assume that each cloud, in order to handle these things, what we are assuming, each cloud has a manager server, right? Suppose you are assuming there are three clouds, okay? Let us assume there are three clouds. So what you can say, these clouds is having a manager server. Okay, each cloud is having a manager server, and this manager server, what they can do, they can keep track about the status of the virtual machine and resources that are present inside a particular cloud or a data center, you can say. In every data center, you require a manager. Without manager, you cannot know that which resources is free, which resources is busy, which resources is live, which resource is means in the sleep state or which is in the wake up state. That you will be able to know through this manager server. So when an application is nothing but your directed acyclic graph, that is nothing but a set of tasks. So when an application arrives, the manager server communicates with other manager server to distribute the task. So whenever an application, for example, this is our cloud, this is another cloud, let me give cloud 1, cloud 2, okay, this is a cloud 3. So each and every cloud has a manager server. So whenever an application is received by a particular cloud, that application will be a very huge application. So what happens once an application is received by a particular manager server of a particular cloud, that manager server is going to contact other manager server in order to execute the applications of the cloud. In order to execute that application of the cloud. Why they are communicating each other? Because the load contributed by the application is very huge. That cannot be handled by a single manager server or single cloud or single data center. That's why the tasks are queued in the respective cloud. Once you have decided which part of the application will be assigned to which cloud, so you can place the task or place the works that are you are going to assign to different cloud. Okay, so each and every cloud contains a particular queue, and the task that are you are going to assign to the cloud that need to be queued in the respective cloud. And if it is assigned to its own cloud, then it will be queued in their own cloud, right? So each and every cloud has a queue in order to maintain the various tasks given by various tasks assigned by the user, right? So, as and when the sufficient number of resources are available, for example, why you are maintaining the queue? Because the number of resources that what you have is limited in comparison to the type of computation you need, right? So, one by one you are going to process the task. That's why you are keeping this task in the queue. So when sufficient number of VMs are available, you have to pick one task from this queue and can assign to a particular resources for its successful execution. So when a task completes execution, it releases all the virtual machine and its corresponding resources. So if the resources occupied by the particular virtual machine, okay, is fully utilized, or the work that is assigned to that particular virtual machine is completed, so the result need to be communicated to the manager server, and that particular user is going to release the resources like virtual machines or the associated resources, so that other people who are in the waiting, they can execute in that using that resources, or that virtual machine is destroyed and a new virtual machine will be created for other users. Okay, so the task scheduling model receives the application in two different modes. This is very important. You are aware of the advanced reservation mode. You are aware of the best effort mode. In advanced reservation modes, you know that there is a specific start time and there is a specific end time, or there is a specific start time and there is a specific duration. Okay, so whatever the task scheduling model, okay, whatever we are considering here, so they are receiving the application either in the form of advanced reservation or in the form of best effort, right? Best effort mode, what happened? You have the duration, but you do not know what is the specific start time. You do not know. There is a specific end time also. You do not know. So whenever the resources becomes available, so that much duration will be given for its execution. And obviously, advanced reservation task has more priority over the best effort task, that you already know, because AR is having a specific start time and end time. So obviously, it has more priority over the best effort task. Or alternatively, you can say the cost of the advanced reservation task, the cost of the advanced reservation task is more than the best effort task, right? So, if there is a best effort task is executing in the system, is advanced reservation is having highest priority, so it can print the best effort you can say task on its arrival or on its scheduled start time. But once a best effort task is printed, once you have decided that best effort task is printed, it is again rescheduled to the same cloud. Very much important. If a best effort task is printed from a resource, okay, or a particular cloud, it should be assigned to the same cloud in method fetch. Okay, that's why I is saying when sufficient VMs are available, it should be resumed in the same cloud only. The AR application cannot print another AR application. That is very much important. One AR application is executing, another AR application asks, they are overlapped with each other. So one AR application cannot print another AR application. So specifically, if you see these type of models are available in our Hygia VM-based release manager. In that case, you can see the model of advanced information and best effort. Now let us see the problem in which we are going to apply the CDD algorithm. So you are given with a set of cloud, right? So you are given with a 10 clouds, that is from C1 to Cn, and you are given with a n application, okay, n number of applications, A1, A2 to An, where each application is either belongs to the AR mode or it belongs to the 3D mode. Okay, one application may be AR, one application may be, right? So it is belongs to one of the mode, not both AR and 3D, right? How you are representing these applications? These applications is nothing but, if you concentrate on application A1 or AI, is nothing but a set of tasks. Okay, with precedence among the tasks. Precedence among the tasks means the tasks are like this. Okay, you can see the tasks are like this. Okay, this is a directed acyclic graph, which is nothing but an application, right? Application in which each and every circle represent or node represent a particular task. Okay, let it be A1. Let this application is A1 and it is a B type application. Let us consider another application A2, which is an AR application, and which looks like this. Right? So what we can say, it is not necessary the number of tasks present in A1 is the number of tasks that is present in A2. Right? Like in this case, you can see the number of tasks present in A1 is 5, and the number of tasks present in A2 is 3. So they are not equal. Okay. So not necessary. It may be equal, it may not be equal, but it is not necessary. But the task that is present in AI should not be divided into AI, right? So if this is a task, this is 1, 2, 3, 4, 5, there are 5 tasks. So you have to give different number to these tasks, 6, 7, 8 tasks. Your application number 2, right? So each vertex, if you see each vertex bi, so these nodes are called as our vertex, right? Belongs to this vertex set, represent a task, and edge is between two different nodes, right? Node A and node B, or node 1, node 2 means the edge is E12. So that is between vertex 1 to vertex 2, which is belongs to the A set, represents the dependency or precedence between the task Bn and task Bn. So in other words, what you can say, the task Bn can only be scheduled after task Bn. Task Bn can only be executed scheduled Bn because there is a precedence relations between 1 and 2. So in this case, you can see 1 need to be executed first, then only 2 and 3 can be executed. Before 1, even if the sufficient number of resources are available, you cannot start with task number 2 or task number 3. Right? So in other words, you can say Bn can only be scheduled if there is a dependency between Bn and Bn like this. Okay, so what you can say, Bn can only be scheduled after this Bn has successfully completed. And Bn should release the resources once it is completed its work. Right? All the virtual machines and resources should be released by Bn so that can be used by Bn. And each application AI has a different arrival time. Like I can say here, the arrival time of the first application is 0, and arrival times of the second application is 1. Right? Or I can say arrival time of the second application is 5. Right? And they are having their ID also. Like here, this is application 1, and this is your application 2. Right? So they have different arrival time, they have different ID, and they are presenting different nodes as well. Like first one is available in the desktop mode, second one is available in the configuration mode. Now, this is the scenario. So whenever we are going for a integration of various cloud service provider, so this may be the scenario. So you can see here there is a cloud service provider, right? You can say this is your cloud 1, this is your cloud 2, this is your cloud 3, this is your cloud 4, right? These 4 clouds have an agreement and they are planning to go for a centralized system. Okay, you can see there is a centralized system, and this centralized system or these portals should be used by the user who is asking for the resources. So a user is requesting the resources to the centralized manager. Once this request is reached to the centralized manager, this centralized manager will decide which manager server can handle this application based upon the capacity of the application and based upon the current node of each and every individual manager server. For example, one manager server is fully loaded, so this portal or this centralized manager should not assign any more load to that particular cloud. If a particular cloud's manager server cloud is completely underloaded, so this centralized manager is going to assign some work to that cloud to the manager server, right? So all the manager servers are coordinating with the centralized manager in order to assign the user application to the resources, right? So they also need to return the result to the centralized manager, and this centralized manager will again return the result to the corresponding user. So this one is called as your centralized architecture, right? But there may be a possibility that instead of going for centralized architecture, as I mentioned here, there is a centralized manager. If there is a failure of the centralized manager, then the entire system is collapsed. just like our start topology, what we have studied in data communication and networking, right? But if you go for distributed architecture, right? In distributed architecture, what happens? This customer is not asking into any centralized manager because there is no centralized manager in the distributed system. So what this user is doing, it is asking the resources to a particular manager server. So your manager server is acting like your centralized manager. So it will check whether whatever resource requirement is there for this particular user that can be possible in this cloud or not. If it is possible in this cloud, then it is fine. It can assign all the tasks to this particular cloud. If it is not sufficient, what this manager server will do, this manager server will coordinate with other manager server in order to divide the work among multiple manager server, and these tasks need to be executed in the corresponding data, corresponding resources of the data set. For example, I have 5 works. What I did, I have assigned 2 works to this particular manager server, 1 work to this manager server, 1 work to this manager server, and I am serving only 1 work as for the my current group. Right? So what happens is here in this case, one manager server is asking the resources to another manager server. Okay, and if it is willing to take some of the load, then we are giving the load to that manager server, right? And obviously you are going to pay for that. Okay, you should not take the money, you have to distribute the money based upon the resources given by various cloud service provider. So this is the complete architecture of the distributed, the task scheduling model in the distributed perspective. So see here, one application is reached to the manager server. This application is nothing but a directed acyclic graph, which is nothing but A is there, A is the root node. Once A is completed, you can start B, C parallelly. Once B is completed, you can start D, but once C is completed, you can start D. If D is started, D will start only if B and C is completed. Once C is completed, you can start E, and also when D is completed, you can start E. So this is the dependency that is given in that particular application. So that is nothing but a workflow as well. Okay, workflow. So when this application reaches to a manager server's first work is to partition the application into a set of tasks. Suppose it has decided it will execute only AD in its cloud. A it will execute and D in its own cloud. Okay, so what it will do, this A and D is going to be assigned to its queue, its own queue. It is also having one queue, okay, task queue. In that task queue, okay, let it be front and let it be rear. So what we are doing, we are assigning AD into the queue. But other applications, although they are having precedence constraint, okay, so when the server is saying, okay, after executing A, I am going to give the data in order to execute at BC, but at that time I am busy, so I cannot execute the work, so this is executed. So once we'll assign BC to some other manager server, in that manager server queue, what you are going to keep, you are going to keep BC. Okay. And finally, E is assigned to another manager server, so in its queue, so you have to keep it. Right? Like that, you have to do. Okay, in this ending. Okay, in the manager's class about perspective. Right? So this may be your, you can say, the centralized system, or this may be a distributed system. So when a client submits his workload, typically an application that is nothing but a directed acyclic graph to a cloud, the manager server, the first work is to partition the application into several tasks. This is a very important point. Once the application is given, how you are going to make grouping. Okay, that is a very important concept in the cloud computing perspective. Then for each task, Each task, what you are going to do? The manager server decides which cloud will execute this task. Okay? Manager server will decide which task it will assign to its own cloud, which task it is going to assign to other. Okay, based upon the information from the other manager server, or based upon the communication with the other manager server, it is going to do that. Okay, and the task dependency and the task. What is the dependency and the various tasks also? It is analyzing. Based upon that, it is saying what is the latency, when content, data metrics, what are the using the data, cloud analyst. The same thing is also applicable to it. So if the manager server assigns a task to its own cloud, then it will store the task in a queue, and when the resources and the data are ready, this task will be executed. Right? So whenever it is assigned to any cloud service, not only its own cloud, so whenever sufficient resources will be available, then it will be executed. So if the manager server of a cloud A assigns a task to cloud B, manager server decides, manager server of cloud A assigns a particular task to X to cloud B. Then the manager server B first checks whether its resource availability can meet the requirement of the task of it. Like you are assigning some work to your friend. So that friend decide whatever work you are assigning, the amount of time what is required for that work, whether that work is possible for him, and for that amount of time, whether he is free or not. If he is free, then the task will enter a queue waiting for the requirement of this task. If not, okay, if so, then the task will enter to the respective queue. If not, the manager server B reject the task so that the manager server of A knows that the task the cloud B is completely busy, so it is going to assign to some other clouds by requesting to some other manager server. So before a task in the queue of a manager server is about to be executed, the manager server should ensure that it has transferred all the disk images to all computing nodes that provide enough memory for task execution. Suppose you are assigning some work to a friend or executing that work, that person requires some money. So you have to ensure that amount of money you should give to your friend, so that whenever he is executing the work on behalf of you, that money can be utilized. Similarly, in this case, whenever you are assigning the work to a particular user, the files associated with this task in the form of this image need to be transferred to the corresponding node. Otherwise, it will not be able to complete the work. Right? So these are the applications. Okay, I will tell you the overall sense. So you can see there are three applications here. One is application 1, another is application 2, application 3 is the application ID. Arrival time of application is 0. Arrival time of application 2 is 3. Arrival time of application 3 is 9. Right? And the number of tasks in each application is different. You can see it is having 5 applications, 5 tasks, it is having 4 tasks, it is having 3 tasks. And the mode of executing these applications are also different. Like A is submitted in the best effort mode. Okay, and the second application is given in the advanced reservation mode. Third application is submitted in the best effort mode. Right? So once this application is assigned to a particular cloud service provider, assume that there are 3 cloud service provider 1, cloud 2, cloud 3. They have collaborated each other. In order to provide services to the customer. Okay. So in order to deal with the peak and fluctuating demand, so these 3 cloud service providers are collaborating with each other. So you can see the first 5 applications, first 5 tasks A to E is representing your application 1, FGH is representing application 2, IJKL sorry, JKL is representing your application 3. Okay, let me correct it. A to E is application 1. Okay, F to I is application 2. J to JKL is application 3. So you can see before assigning these applications, as you have the data, okay, how much data you are going to process or how much computational power is required. Based upon that, you tentatively calculate how much time it will take in the respective cloud. For example, in this case, you can say task A, if it is assigned to cloud 1, it takes 2 units of time. 2 units of time. This time may be any unit, maybe nanosecond, picosecond, second, minute, hour, day, something like that, month, any time unit, okay? And you can see if A is assigned to the cloud 2, it is taking 3 units of time. If A is assigned to cloud 3, it is taking 5 units of time. Okay, why they are taking different kind? Because the computational resources of each and every cloud service provider is different. Okay, similarly, you can see for the task F, task 1 is taking, cloud 1 is taking 4 units of time, cloud 2 is taking 2 units of time, cloud 3 is taking 3 units of time. Okay, this is calculated based upon the requirements given by the user applications and the amount of work that can be processed by a particular cloud, right? So once this matrix is given, this matrix is called as expected time to complete matrix. Expected time to complete matrix, sometimes we call it a expected execution time matrix as well, right? So once this matrix is given, you can apply a task scheduling model into this particular resources, right? You can assign resources, okay, based upon the these times, right? For example, if you want to go for the very popular algorithm what you studied in the operating system, that is round robin algorithm, okay? So round robin says that first task should be assigned to first cloud, second task should be assigned to second cloud, third task is assigned to third cloud, fourth task, as you have 3 cloud, fourth task should be assigned to the first cloud, fifth task should be assigned to the second cloud. Similarly, whenever you are changing from one application to another application, you have to again start from the beginning. So F is assigned to the first cloud, G is assigned to the second cloud, H is assigned to the third cloud, and I is assigned to the first cloud. Similarly, here J is assigned to the first cloud, A is assigned to the second cloud, L is assigned to the third cloud. Right? So you can see there is a sequence here 1, 2, 3, 1, 2. Okay, here one application end. Okay, then 1, 2, 3, 1, then 1, 2, 3. Right? In this way, RR scheduling algorithm assigns. But what is the demerit? Demerit is start looking how much time that task required in a particular resource. Simply following 1, 2, 3 R. Because there are 3 clouds. So in order to avoid this, what you can go for the list scheduling. List scheduling, which is represented by SCH. What list scheduling is saying? So here list scheduling is saying whenever you want to assign a particular task to a resource, you have to see how much time it is taking in different cloud. So you can see here it is taking 2 units of time in cloud 1, 3 units of time in cloud 2, 5 units of time in cloud 3. Out of these 3, which one is minimum? The first one is minimum. So you assign task 1 to first cloud. Okay. B case, it is taking 6 units of time in cloud 1, 8 units of time in cloud 2, 4 units of time in cloud 3, out of which the minimum is 4, so it is assigned to the third cloud. Okay. Similarly, C case, the minimum is 2, so it is assigned to second cloud. D case, the minimum is 5, so it is assigned to third cloud. E case, it is assigned to the third cloud. Okay. F case, it is minimum is here, so it is assigned to the second cloud. And the G case, it is assigned to the third cloud. Okay. H case, it is assigned to the first cloud. I case it is assigned to the first cloud. There is a mistake here. You should write 1. Okay. J case it is assigned to the second cloud, and K case it should be assigned to the second cloud. L case it should be assigned to the first cloud. In this way, you are going to schedule the applications or a set of tasks under that applications in the cloud. The clouds using a particular task scheduling